Dear students, today we are going to discuss basic mathematics and physics. So, mathematics is extensively used in solving the problems of physics. Today we are going to discuss a small topic on calculus, that is differentiation. Calculus has limited applications when you study up to NEET level, but when you go to mains and advanced levels, the use of calculus is very extensive. So let us try to understand some of the basic concepts of calculus today, that is the part of differentiation. So, calculus can be divided into two parts. One is differentiation. Second one is integration. So, let us try to understand the difference between these two mathematical tools by taking a very small example. So, differentiation, we can say it is analogous to splitting of a physical quantity into very small physical quantities, that we can say it is analogous to differentiation. Similarly, if we take integration, it is the summing up of the results of very small physical quantities. This we can call it as integration. For example, let us take an example. For example, this is a body of mass capital M and its mass is unknown. We doesn't know the mass of this one. So we have a very small mass of small m, which is equals to 1 kg. Now I want to compare the total mass of this unknown body with respect to this small mass whose mass is equal to 1 kg. Then what can I do is, I can split this bigger mass of unknown quantity into very small masses whose each mass is equals to 1 kg. Like this, we can split this one. So here, every mass which we have divided, that is equals to the mass of 1 kg. So therefore, for example, if I got, let us say 12 masses of 1 kg, therefore this total mass can be written as m plus m plus m up to 12. Okay, so this splitting of masses, this is analogous to differentiation. And this summing of masses up to 12 masses, that is addition of all the small physical quantities, we can call it as integration. So this is the basic difference between this differentiation and integration. So let us see what is the actual meaning of this differentiation. For example, let us take a function y is equals to f of x. So what is meant by this function? Function represents that this value y, it depends on the value of x. For example, if we write a relation y is equals to 5x plus 3, then here I can substitute any value of x. For example, if I can substitute x value is 0, 1, 2, 3 like this. But for each value of x, we get a different value of y here. So it means that the value of y depends on the value of x here. So this x we can call it as independent variable. So independent in the sense that this x value can be given any value ranging from 0 to infinity. And this y value cannot have all the values because it is depending upon this function 5x plus 3. So this variable we can call it as dependent variable. So similarly, if we can write any relation between y and x, that is called as a function. That is, y depends on the value of x in this condition. Similarly, if we can write y is equals to tan x plus secant x, this is also a function. So depending on the values of this x, this y value depends upon. So this is called a function. Now, let us see if we take a function y is equals to f of x. Now I want to change this x value by a small amount. Then if x value changes by a small amount, this y value also changes by a small amount. So let us take this equation as equation number 1. So x value, let us suppose it has changed from x to x plus delta x. Then y value will change from y to y plus delta y. Then how can I write the second equation in terms of the changed conditions of x and y? We can write it as y plus delta y is equals to f of x plus delta x. So let it be our equation number 2. So this is our equation number 1. This is our second condition. When x value has changed, then y value also has changed in this condition. So let us do 2 minus 1. So y plus delta y minus y is equals to f of x plus delta x minus f of x. So this is how we got the condition. So we can cancel y and y. So delta y is equals to f of x plus delta x minus f of x. Now divide both the left hand side and right hand side by delta y, delta x. Then we can write delta y by delta x is equals to f of x plus delta x minus f of x divided by delta x. So up to here we got the condition. Now here in the denominator we have taken delta x. So let us take delta x is very small. That is, the change in x value is very, very small. Then how can I write this one mathematically? I can write it as limit delta x tends to 0, delta y divided by delta x is equals to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. So this change in x value, if it is very, very, very small, then the change in delta y will also be very, very small. So therefore this relation can be written as dy divided by dx. So this is basically what is the meaning of differentiation. That is, we can say it is the ratio of change in dependent variable to the change in independent variable. This we can call it as the basic meaning of differentiation. Okay. So let us take some examples based on this condition. For example, let us take y is equals to 6x plus 7. This is the given function. Now we have to suppose that x value changes from x plus delta x, then y value will change from y to y plus delta y. Then we can write it as y plus delta y is equals to 6 into x plus delta x plus 7. So y plus delta y is equals to 6x plus 6 delta x plus 7. Now if we observe this condition, here we got 6x plus 7, which is equals to the value of y here. So therefore I can cancel this y value, 6x and 7. Therefore the value which I get is delta y is equals to 6 delta x. Now here we apply the same condition. So when delta x tends to 0, then it will become dx. So for a very small change in dx, we get dy, very small change in dy. So therefore this relation can be written as dy is equals to 6 dx. So dy by dx is equals to 6. This is the answer to our problem. So this is how we can understand what is the meaning of differentiation in this condition. So very small change in dy to very small change in dx. This is called as differentiation. So now the question is, where we use these mathematical conditions in physics. Let us take an example of this one. For example, when we study the topic of thermodynamics. So here we have different state variables like pressure, temperature and volume. Then we study how pressure changes when volume changes. That can be written as dP divided by dV. Similarly, we can also calculate how temperature changes when pressure changes. That can be written as dt divided by dP. So these are the conditions which we study in thermodynamics topic. So this is nothing but small change in pressure to small change in volume, small change in temperature divided by small change in pressure. These are the applications where we use in physics. Similarly, there are many more applications. Let us see one more example of this one. For example, function is given like this: y is equals to 4x square plus 6x plus 7. Now we substitute the small changes in x value, and similarly we substitute small changes in y value also. Then y plus dy is equals to 4 into x plus dy whole square plus 6 into x plus dy plus 7. So y plus dy is equals to 4 into x square plus 2x dy plus dy whole square plus 6x plus 6 dy plus 7. So here we get the equation up to here. So y plus dy is equals to 4x square plus 8x dy plus 4 dy square plus 6x plus 6 dy plus 7. So here if you observe this, this is dx, 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 this is dx, here also dx, dx square, this is dx. Now when we see this condition, this dx square will become very small value, because dx tends to 0. It is a very small fractional value. So dx square will be very small, so we can neglect this value here. So therefore the remaining values which we got are y plus dy is equals to 4x square plus 8x dx plus 6x plus 6 dx plus 7. Now when we compare this equation with the original equation, then see what are the terms we got: 4x square, 6x and 7. So this 4x square plus 6x plus 7, which is equals to y value, so we can remove this y, this 4x square, this 6x and this 7. So the remaining terms which we got are, so dy is equals to 8x dx plus 6 dx. So dy divided by dx is equals to 8x plus 6. So this is the answer to our problem. So this is how we can solve dy by dx values with the help of the small changes in x values to the small changes in y values. Okay. So based on these results, we have calculated some, we have found out some rules of differentiation. Let us see those rules now. So before studying these rules, let us see how many types of functions we generally study in physics. So in physics generally we study 6 types of functions. So 6 types of functions we study in physics. First one we can call it as algebraic function. Second one, trigonometric function. Third one, inverse trigonometric function. Fourth one, logarithmic function. Fifth one, exponential function. And sixth one, mixed function. So we know these values. Algebraic function, we can write it as y is equals to 6x square plus 2x plus 7. Trigonometric function, y is equals to sin x, y is equals to cos x plus tan x. Inverse trigonometric function, y is equals to sin inverse x. Logarithmic function examples we can write y is equals to log x. Exponential function example we can write y is equals to 5 power x, or we can write y is equals to e power x. Mixed function means it is a combination of any of these 2 functions or 3 functions or more. For example, we can write y is equals to log x plus tan x. So these are the different types of functions generally we study, generally we use in solving the problems of physics. So let us study these functions in detail. For example, if I take algebraic function, so example of algebraic function, y is equals to 6x square plus 2x plus 9. This type of function we call it as algebraic function. So there are certain rules of differentiation in the case of these algebraic functions. Let us see those rules. Rules of differentiation. For example, first one, let us take y is equals to x power n. Then dy by dx can be written as n into x power n minus 1. This is our first one. Second one, let y is equals to 1 by x. Then dy by dx can be written as minus 1 by x square. So how we got this minus 1 by x square? Let us see. So y is equals to 1 by x can be written as x power minus 1. So therefore dy by dx can be written as minus 1 into x power minus 1 which is equals to minus 1 by x square. So basically this rule have been derived from the same formula of x power n is equals to n into x power n minus 1 itself. Let us see one more rule of differentiation of algebraic functions. For example, we can take y is equals to root x. Then dy by dx is equals to 1 by 2 root x. This is one more rule which we have. Same, this rule also is basically derived from the first rule itself. Let us see that also. So y is equals to root x can be written as x power 1 by 2. So dy by dx can be written as 1 by 2 into x power 1 by 2 minus 1. So half into x power minus 1 by 2, which is called half into x power, or we can write half into 1 by root x, which is called 1 by 2 root x. So basically the second rule and third rule are basically derived from the first rule itself, n into x power n minus 1. So we can study one more rule. For example, y is a constant. Constant is k. Then dy by dx will become 0. Differentiation of a constant is always a 0. Let us see one more condition. For example, we can say y is equals to k into u, where k is a constant. Then I want to find out dy by dx. Then this equation, how can I write? As k is a constant, this cannot be differentiated, I take it outside. So I will write k into du divided by dx. Though these are some of the rules which we have in differentiation of algebraic functions. Let us see some examples based on this one very fastly. So first one, so y is equals to 6x square plus 2x plus 7 dy by dx is equals to 12x plus 2. This is our answer. This we know, 6 into, so this is of the form of x power n, so n into x power n minus 1. So 6 2s are 12, x power 2 minus 1 is x. So differentiation of 2x, dx by dx is 1. So 2 here we got. Differentiation of 7 is 0 because 7 is a constant. Let us see one more example. Y is equals to 5x cube minus 7 by x plus 6 root x. Let us see how we can differentiate this one. dy by dx is equals to 5 3s are 15x square. So differentiation of 1 by x is minus 1 by x square. So minus and minus will become plus. So plus 7 by x square plus 6 into differentiation of root x is 1 by 2 root x. So 1 by 2 root x. This is our answer to our problem. So here also we can write 2 3s are 6 also. So 3 by root x also can be written. So this is how we can study the differentiation rules in algebraic conditions. Let us see what are the rules which are present in differentiation of trigonometric functions also. So we can write formulae for differentiation of trigonometric functions. So first one, let us see, y is equals to sin x, then dy by dx is equals to cos x. Second one, y is equals to cos x, dy by dx is equals to minus sin x. Third one, y is equals to tan x, dy by dx is equals to secant square x. Fourth one, y is equals to cosecant x, dy by dx is equals to minus cosecant x cot x. Similarly, y, this is fifth one. So y is equals to secant x, dy by dx is equals to secant x tan x. Sixth one, y is equals to cot x, dy by dx is equals to minus cosecant square x. So these are some of the differentiation rules which we have in trigonometric functions. Similarly, let us see the rules which are present in inverse trigonometric functions. So formulae of differentiation in inverse trigonometric functions. So first one, y is equals to sine inverse x, then dy by dx is equals to 1 by square root of 1 minus x square. Second one, y is equals to cos inverse x, dy by dx is equals to minus 1 by square root of 1 minus x square. Third one, y is equals to tan x, dy by dx is equals to 1 by 1 plus x square. Fourth one, y is equals to cot x, dy by dx is equals to minus 1 by 1 plus x square. Fifth one is equals to y is equals to inverse secant inverse x, dy by dx is equals to 1 by x into square root of 1 minus x into square root of x square minus 1. Sixth one, y is equals to cot inverse x, so dy by dx is equals to minus 1 by x into square root of x square minus 1. So we will continue this basic mathematics in the next class. Thank you. Dear students, so today we are going to do basic mathematics differentiation part 2. So let us see. So in the first part we have done a small mistake. There y is equals to cosecant inverse of x, then dy by dx is equals to minus 1 by x into square root of x square minus 1. So in the last part, instead of this cosecant inverse x, we have written cot inverse x. So make this correction. Now after this, let us study about logarithmic functions. So let us first try to understand how we write these logarithmic functions. So for example, we have x is equals to y power z. So this is an algebraic function. So in terms of logarithms, how we can write this one is, we can write log x to the base y is equals to z. So this is called a logarithmic function. For example, let us write 2 power 3, 2 cube is equals to 8. Then in terms of logarithms, how we can write? We can write log 8 to the base 2 is equals to 3. So this is how we write these logarithmic functions, or we can say 2 power 3 is equals to 8. So these logarithmic functions have some properties. Let us see those properties of logarithmic functions. Properties of logarithmic functions. First property we can write log ab to the base x can be written as log a to the base x plus log b to the base x. Second one, log a by b to the base x can be written as log a to the base x minus log b to the base of x. Third property can be written as log a power b to the base x is b into log a to the base x. So three properties. We have one more property which we can call it as base change property. So let us see this fourth property which is called base change property. So, for example, we have a logarithmic function log x to the base a. This can be written as log x divided by log a, and the base can be written as any base. For example, we can write it as log x to the base b divided by log a to the base b. Similarly, we can write log x to the base c divided by log a to the base c. Therefore, instead of this c, we can write e also, which is called exponent value. Can be written as log x to the base e divided by log a to the base e. And what is this e? This e is a constant which has a value of 2.71. And this e value is very extensively used in physics. So this log to the base e, we can also call it as natural logarithm. So the same function can also be written as ln x divided by ln a also, which is called natural logarithm. So log of anything to the base e, we always call it as natural logarithm, and to differentiate with other bases, we call it as ln. So ln x divided by ln a. So these are some of the properties of our logarithmic functions. Now let us see the differential rules of this logarithmic functions. So, differentiation rules of log functions. First one, for example, if we have y is equals to ln x, then dy by dx can be written as 1 by x. Second one, we have y is equals to log x to the base a. So here we are not using the natural logarithm, we are using the log to the base a in this condition. This can be written as, already we have discussed this one, we can write as ln x divided by ln a. And if I want to do dy by dx in this condition, that is the differentiation of y with respect to x, then in this condition ln a becomes a constant, therefore I can write 1 by ln a, and differentiation of ln x is 1 by x. Therefore the function, the answer becomes 1 by x ln a. So these are the differentiation rules of logarithmic functions which we have. Now next let us see the differential rules of exponential functions. So first one, for example, we take y is equals to e power x, then dy by dx is equals to e power x only. Second one, y is equals to a power x, then dy by dx can be written as a power x ln a. So these are the two differential rules of exponential functions. Now after this, let us see the arithmetic rules of differentiation. So, first one we call it as addition rule. For example, we have y is equals to u plus v, then dy by dx, differentiation of y with respect to x, can be written as du by dx plus dv by dx, and this rule is called addition rule. So the next rule which we can understand is should be subtraction rule. Here let we have y is equals to u minus v, then dy by dx can be written as du by dx minus dv by dx. And the third rule which we have is, we can call it as the product rule. So here we have y is equals to u into v, then dy by dx can be written as u dv plus v du. This we call it as the product rule. And the fourth rule which we have is called division rule. Also we can call it as quotient rule. So here, for example, if we have y is equals to u by v, then dy by dx can be written as v du by dx minus u dv by dx divided by v square. So these are the four arithmetic rules of differentiation which we have in differentiation concept. So after this, let us see some examples based on this one. For example, we have y is equals to x square plus 2x plus 7 into 3x power 4 plus 3x plus 6. So this is the given function, and I want to calculate dy divided by dx. So this function is the form of y is equals to u into v. That is the product rule we can use in this condition. So dy by dx is equals to x square plus 2x plus 7, and the differentiation of the second term will become 4 3s are 12x cube plus 3 plus, now we write this term 3x power 4 plus 3x plus 6, and then we differentiate the first term which is called 2x plus 2. So this is the answer to this problem. Let us see one more example of this one. For example, same question we can write like this: y is equals to x square plus 2x plus 7 divided by 3x power 4 plus 3x plus 6. Now this function is the form of y is equals to u by v. So let us see how we can calculate a dy by dx for this condition. So 3x power 4 plus 3x plus 6, and the differentiation of the numerator will become 2x plus 2. Minus of, now we write the first term x square plus 2x plus 7, and the differentiation of the denominator will become 12x cube plus 3x plus 3 divided by v square. So v in this condition is 3x power 4 plus 3x plus 6 whole square. So this is the answer to our problem. So until now we have completed all these functions. What are the functions? Algebraic functions we have studied. Trigonometric functions, inverse trigonometric functions. Next we have studied this logarithmic functions and exponential functions also. Now let us see one more type of function which is called composite function. Composite function is a function which has a function which there is a function which is present in another function. So if we say if there is a function inside function, then this type of function we call it as composite function. For example, we take y is equals to ln of 2x square plus 3x plus 6. So here y value, it is not directly depending on this given relation. It is depending on the natural logarithm of this given relation. So there is a function which is present in another function. So this type of functions we call it as composite functions. So let us see how we can solve these composite functions. So the method of solving these composite functions is the function which is present inside another function. We assume this function with a new variable. So let us assume here we can take 2x square plus 3x plus 6 is equals to p. Now the equation, the function becomes y is equals to ln of p. Now we differentiate the main function with respect to the new variable which we have taken. That is, first of all, I will calculate dy divided by dp. So dy by divided by dp is 1 by p. We know this. So let us take it as equation number 1. Now differentiate the new variable which we have taken with respect to x again. So dp divided by dx is equals to 4x plus 3. So this is our equation number 2. So what we are supposed to find out here is we are supposed to find out dy by dx, the differentiation of y with respect to x. This is what we are supposed to find out. So here we got dy by dp, which is equation number 1, and here we got dp by dx, which is our equation number 2. From these two, we are supposed to find out dy divided by dx. So what can I do in this condition is, I will multiply 1 with respect to 2. Therefore, I will get dy by dp into dp divided by dx, which is 1 by p into 4x plus 3. So this dp gets cancelled. The final result is dy by dx is equals to 4x plus 3 divided by p. And p is the assumed variable which we have taken. So this 4x plus 3 divided by, instead of p I can write 2x square plus 3x plus 6, and this is the answer to our problem. So this is one method of solving a composite function. Composite function means if a function is present inside another function, then we use this method to solve this problem. Now, we feel this method of substitution is a very long method of solving the problem. So we have another method of solving this composite function, which is called as a chain rule. So let us try to understand this rule. So what is the given function? This one. So let us try to do the same problem in the method of chain rule. For example, the same equation we will take, y is equals to ln of 2x square plus 3x plus 6. So here we have assumed a new variable 2x square plus 3x plus 6 is equals to p. So without substitution, directly we can solve it with the help of chain rule. So here what we can do is dy by dx is equals to ln of this total, we call it as a new variable. So ln of p, just we can write 1 by x, so 1 by 2x square plus 3x plus 6. So until now we have differentiated this ln p. We have not differentiated this p. So again we differentiate d by dx of this variable, this equation 2x square plus 3x plus 6. So therefore 1 by 2x square plus 3x plus 6 into differentiation of this equation will give 4x plus 3. So this is the answer to our problem. So 4x plus 3 divided by 2x square plus 3x plus 6. So let us take some more examples of this composite functions. For example, if we take a function y is equals to 1 by sin x plus tan x. This is the given function, and we want to calculate dy divided by dx. So let us see how we can do. So dy by dx is equals to this total, I can take it as 1 by x. So differentiation of 1 by x is minus 1 by x square. So minus 1 by sin x plus tan x whole square, and now we differentiate dy by dx of this function which is given sin x plus tan x. So the next step should be dy by dx is equals to, so differentiation of sin x is cos x and differentiation of tan x is secant square x divided by this function which we got here is sin x plus tan x whole square, and this is the answer to our problem. Okay, so see if we have committed any mistake in this condition. It's cos x plus secant square x. Yes, this is our problem. So let us see one more example of this one. For example, let us take y is equals to e power 2x and dy by dx is equals to e power 2x, and the differentiation of 2x is 2. So this is our problem. Let us take one more example of this one. Y is equals to e power tan x square, then dy by dx is equals to e power tan x square, and now we take the differentiation of tan x square. Differentiation of tan x square is secant square x square, and now again we take the differentiation of x square, which is called 2x. So this is the answer to our problem. So 2x into secant square x square into e power tan x square. So let us see some more examples of this chain rule. So let us take y is equals to square root of x plus 1 by x, this condition. So this is of the form of y is equals to root x. So dy by dx is equals to 1 by 2 root x, so 2 into square root of x plus 1 by x. Now we again differentiate this total equation which is given, that is x plus 1 by x. So d by dx of x plus 1 by x. Therefore dy by dx is equals to 1 by 2 into square root of x plus 1 by x, and the differentiation of x is 1, differentiation of 1 by x is minus 1 by x square. So this is the answer to our problem. Let us see one more example of this one. For example, the given function is y is equals to e power sine y is equals to 5 power sine x. So this is the form of y is equals to a power x. So we know dy by dx is equals to 5 sine x, a power x into ln a, ln 5. Now again we have to differentiate this sin x. Differentiation of this sin x is cos x. This is our answer to our problem. So y is equals to in the form of a power x. So differentiation of a power x is a power x ln a. We have not differentiated this sin x. So again the differentiation of sin x will become cos x in our condition. So similarly, let us see one more example of this one. For example, we have y is equals to ln cos 5 power x. This is the given condition. So let us see. So dy by dx is equals to, so ln x is 1 by x, and the differentiation of cos 5 power x is minus sine 5 power x. And again we have to differentiate 5 power x, which is called 5 power x ln 5. So this is our answer. So differentiation of ln x is 1 by x. So 1 by x means 1 by cos 5 power x in this condition. And the differentiation of cos power 5x is minus sine 5 power x. And the differentiation of 5 power x is 5 power x ln 5. So this is how we can apply the composite function in the case of differentiation. So similarly, let us see one more example of this one. Let us try to understand function to the power of function. If this type of functions are given, then how can we solve these problems? Let us see them. So, for example, the given function is y is equals to x power x. We are supposed to find out dy by dx. Then if I write x into x power x minus 1, this is a wrong method of solving, because this is of the form of function to the power of function. So in this type of problems, I can solve these problems very easily by taking logarithmic functions. So the given function is y is equals to x power x. So take log on both sides. Ln y is equals to ln x power x. So ln y it can be written as x ln x. Now you differentiate these two with respect to x. Then I can write it as 1 by y dy by dx is equals to, this is of the form of u into v. Therefore I can write x differentiation of ln x is 1 by x plus ln x into differentiation of x is 1. So 1 by y dy by dx can be written as 1 plus ln x. Therefore dy by dx can be written as 1 plus ln x into y. So this is the answer to our problem. So wherever this type of functions is given, that is function to the power of function is given, then always we can use the condition of logarithms. We apply logarithms and we can solve these problems. So let us see one more example of this function to the power of another function. For example is given like this. So y is equals to sin x to the power of cos x. So this is also of the form of function to the power of another function. So generally we apply logarithms. So ln y is equals to ln sin x to the power of cos x. So ln y is equals to cos x into ln sin x. Now differentiate on both sides with respect to x now. So it will become differentiation of ln by v is 1 by y, and differentiation of y is dy by dx. So again this is of the form of u into v. So we can write it as cos x into ln sin x is 1 by sin x, and the differentiation of sin x is cos x plus, now we write ln sin x, and the differentiation of cos x is minus sin x. So this can also be simplified like this. So 1 by y dy by dx can be written as, so here cos x by sin x, I can write it as cot x. So cot x into cos x minus sin x into ln sin x. So I want only dy by dx. So dy by dx is equals to y into cot x into cos x minus sin x into ln sin x. So dy by dx is equals to, so what is y? Y is sin to the power of cos x, so we can substitute that value here. So sin x to the power of cos x into cot x into cos x minus sin x into ln sin x. So this, let us see one more important question in differentiation. For example, y is equals to square root of 1 plus sin 2x divided by 1 minus sin 2x. So y is equals to square root of, 1 can be written as sin square x plus cos square x. So sin square x plus cos square x plus sin 2x divided by sin square x plus cos square x minus sin 2x. So y is equals to square root of sin square x plus cos square x. Sin 2x can be written as 2 sin x cos x divided by sin square x plus cos square x minus 2 sin x cos x. So this is of the form of a square plus b square plus 2ab. This is of the form of a square plus b square minus 2ab. So therefore it can be written as y is equals to square root of sin x plus cos x whole square divided by sin x minus cos x whole square. So we can cancel these squares and roots here. So the relation which we get is sin x plus cos x divided by sin x minus cos x. Now we are supposed to find out dy by dx. This relation, we know it is of the form of u by v. So therefore by applying the rule, we get sin x minus cos x, and differentiation of u is cos x minus sin x, minus of sin x plus cos x, and differentiation of this v is cos x, minus of differentiation of cos x is minus sin x. So minus of minus sin x will become plus sin x divided by sin x minus cos x whole square, which is called v square. So we got the relation up to here. Now if we observe these two equations, so if I can take a minus common out of this equation, then it will become minus of sin x minus cos x. So the same equation can be written as dy by dx is equals to minus of sin x minus cos x into sin x minus cos x. Minus of, this is of a into a, which is called a square. So we can write sin x plus cos x whole square divided by sin x minus cos x whole square. So we got the relation up to here. Let us see what we can do after this one. So dy by dx is equals to minus of sin x minus cos x whole square minus sin x plus cos x whole square divided by sin x minus cos x whole square. Now we see here, this is of the form of a minus b whole square, this is of the form of a plus b whole square. So here you will get minus sin square x minus cos square x. Here also you will get minus sin square x minus cos square x. So let us see what happens in this condition. So here you will get minus 2 sin x cos x, minus of minus plus. Here you will get minus 2 sin x. So this gets cancelled. So the terms which we will get is dy by dx is equals to minus sin square x minus cos square x. Here also we will get minus sin square x minus cos square x. So 2 sin x cos x here and 2 sin x cos x in this condition are getting cancelled. So we got the remaining terms, these terms. So sin x minus cos x whole square. So dy by dx is equals to, this we can write it as minus 2 sin square x minus 2 cos square x divided by sin x minus cos x whole square. So dy by dx is equals to, if I take minus 2 common, then I will have sin square x plus cos square x, which is equals to 1. So therefore the result is minus 2 divided by sin x minus cos x whole square, and this is the answer to our problem. Dear students, today let us see the concept of integration. So how can we define integration? It is called an antiderivative. It is the reverse process of differentiation. Reverse process in the sense, for example, let us take an example. If we take a function y is equals to f of x, if I differentiate this one, then I will get f dash x, and if I again integrate this one, then again I will get f of x. So a function on differentiation give f dash x, and on integration again it will give f of x. That is, here integration nullifies the effect of differentiation. That is how we can call integration. So therefore we can say integration removes or nullifies the effect of differentiation. So this is how we can define integration. So let us see integration in some more detail. We have two types of integration. One we can call it as definite integration. Second one is indefinite integration. Definite integration in the sense, this integration is carried within certain limits. So there will be certain limits of integration under which we will do this integration. There will be one upper limit and there will be one lower limit. Whereas if you take indefinite integration, there will be no such limits. So let us take an example of indefinite integration. For example, if we take y is equals to 6x plus 7, another function y is equals to 6x plus 8. Let us differentiate this function with respect to x, then dy by dx is equals to 6. Here also if I differentiate, dy by dx is equals to 6. Now if I integrate this function again, then I should get the original function. So let us see. So this relation can be written as dy is equals to 6 dx. Here also I can write dy is equals to 6 dx. Now we apply integration on both sides. Integration, integration, integration and integration. So then this integration and differentiation, they are just opposite, so they just get cancelled. So I will write y is equals to integration 6 dx. Here also I will get y is equals to integration of 6 dx. So y is equals to integration of 6 dx is 6x. Here also y integration of 6 dx is 6x. So on integration again, we got these relations y is equals to 6x and also y is equals to 6x. But here we did not get any idea about the constants which are present. Here the constant present is 7, here the constant present is 8. So there is no idea on this constant. So therefore always in the case of indefinite integration, we always indicate that unknown constant by a term called c plus c. So here also we write it as plus c. So always in the case of indefinite integration, after doing the integration, we write a constant called plus. So this point we go on writing the c values and all these integration concept now. So after this, let us see some of the formulae of integration. For example, formulae of integration. So all these formulae of integration can be obtained basically from the formula of differentiation itself, because integration is the reverse process of differentiation. So let us see some examples. First one, d by dx of x power n plus 1. So we know what is the result of this one. We can write it as n plus 1 into x power n plus 1 minus 1. So therefore n plus 1 into x power n. This is the result. So let us try to integrate this one and let us see what is the answer we will get. The same relation we can write it as d of x power n plus 1 is equals to n plus 1 into x power 1 x power n dx. This is how we can write. Now let us take this constant to this side. So d of x power n plus 1 divided by n plus 1 is equals to x power n dx. Now let us try to integrate on both sides. So we get this integration and differentiation gets cancelled. So then see what is the result we got. We got integration of x power n dx is equals to x power n plus 1 divided by n plus 1, and we have to place a constant, just we discussed now, and this is our answer. So integration of x power n dx is equals to x power n plus 1 divided by n plus 1 plus c. So that is our answer. So this is a very important formula in integration. Very carefully we should remember this formula. So let us see one more formula. So let us write d by dn of d by dx of ln n ln x. So this relation also we have discussed in the previous lectures. So this can be written as 1 by x. Differentiation of ln x is 1 by x. Now we have same, just we have written in the previous condition. Let us see how we can write this one. So d of ln x is equals to 1 by x dx. So therefore now if you apply integration on both sides, this and this gets cancelled. So ln x is equals to integration of 1 by x dx. So therefore integration of 1 by x dx is equals to ln x plus c. So this is our second result. So in this condition and this condition, there is a small exception here. So integration of x power n dx, this can be applied for any power of n except n value is equals to minus 1. N value cannot be equal to minus 1 because this is that condition. So here integration of 1 by x can be written as x power minus 1 dx. So then what should be our answer? Integration of x power minus 1 dx should be equal to x power of minus 1 plus 1 divided by minus 1 plus 1. Minus 1 plus 1 is 0 and this is indefinite. So this is a wrong method of calculation. So this formula cannot be used for n is equals to 1. So sorry, n is equals to minus 1. So this we have to remember in this condition. Let us see one more relation. So d by dx of 1 by x, then this is equals to minus 1 by x square. So therefore how can I write in the same process? We can write it as d of 1 by x is equals to minus 1 by x square into dx. Therefore now if we apply the integration values, 1 by x is equals to integration of 1 by x minus 1 by x square into dx. Therefore integration of 1 by x square dx is equals to 1 by x plus minus 1 by x plus c. So these three formulae we have written. Let us see some more formulae of this integration. So previously we have studied one more formula of this differentiation, that is formula number 4, d by dx of root x. This we have written 1 by 2 root x. Therefore again let us do in the same method. D into root x is equals to 1 by 2 root x into dx, apply integration limits and integrations, then root x is equals to integration of 1 by 2 root x into dx. Therefore, we can write integration of 1 by root x is equals to 2 root x plus c. So this is one more formula which we can write. So when we observe here, all these formulae of integration are basically derived from the formula of differentiation itself. That is what I am trying to explain in this lecture. Similarly, let us see one more formula. D by dx of e power x is equals to e power x. Therefore, we can write integration of e power x is equals to e power x plus c. Same formula doesn't change in this condition. Let us see one more relation. So, d by dx of ln x can be written as d by dx of a power x can be written as a power x ln a. Therefore, again, if we do in the same method, d of a power x is equals to a power x ln a into dx. Therefore, if I apply this integration values, a power x by ln a is a constant, so we can take it to this side. So this is equals to integration of a power x dx. Therefore, we can write integration of a power x dx is equals to a power x by ln a plus c. So these are some of the formulae we have in integration. Similarly, we have some more formulae in trigonometry also, trigonometric ratios. Let us see those relations also. So, formulae of trigonometric ratios. First one we have d by dx of sin x is equals to cos x. Therefore, integration of cos x dx can be written as sin x plus c. Second one, d by dx of cos x is equals to minus sin x. Therefore, integration of sin x dx can be written as minus cos x plus c. These relations, if you observe, are just getting the reverse what you call results of differentiation. Let us see the third one. D by dx of tan x is equals to secant square x. Therefore, integration of secant square x dx is equals to tan x plus c. Fourth one, d by dx of cosecant x is equals to minus cosecant x cot x. Therefore, integration of cosecant x cot x is equals to cot x dx. That is, we are integrating with respect to dx here. So this is equals to minus cosecant x plus c. Fifth one, d by dx of secant x is equals to secant x tan x. Therefore, integration of secant x tan x dx is equals to secant x plus c. Similarly, we have one more relation, d by dx of cot x is equals to minus cosecant square x. Therefore, integration of cosecant square x is equals to minus cot x plus c. So these are the formulae for integration of trigonometric ratios. Let us see some standard rules which we have in integration. So these rules are very important in applying the integration rules. Let us see. So we call them as rules of integration. First one, integration of k f of x dx, where k is a constant. Then we take this k outside. So this can be written as k into integration of f of x dx. Second one, so integration of f of x plus g of x dx. So in this condition, if we have two functions, then how can I write? I can write integration of f of x dx plus integration of g of x dx. This we know. Similarly, let us see one more very important rule of integration. Third one, integration of ax plus b whole power n dx. This can be written as ax plus b whole power n plus 1 divided by n plus 1 into 1 by a. Sima, in this condition, this ax plus b is a linear function. Linear function in the sense, here we have x power plus 1. So therefore, in this type of linear functions, we write this relation ax plus b whole power n plus 1 divided by n plus 1 into 1 by the coefficient of x which is present here. This we are supposed to write in this condition. So these are the three rules of integration which we are studying up to here. So if we just study some of the examples of this third relation, let us see. So we can write example integration of 3x plus 7 whole power 6 dx. So this can be written as 3x plus 7 whole power 6 plus 1 divided by 6 plus 1 into 1 by a. What is a here? A is the coefficient of x which is called as 3 plus c. So therefore 3x plus 7 into 7 divided by 7 3s are 21 plus c. This is our answer. So let us see some more examples of this one. For example, if we write integration of 9 minus 3x power 6 dx, then how can I integrate this one according to the third formula? So this here also same condition, 9 minus 3x power 6 plus 1 divided by 6 plus 1 into 1 by the coefficient of x. Here the coefficient of x is minus 3, so we write minus 3 plus c, and this is the result of our answer. So further you can simplify this one. So minus 3 into 7 minus 21, so you can write like this. So let us see one more example. So integration of 1 by 2x minus 3 whole power 4 plus 1 by 2 minus 3 by 7x whole power 6 dx. Then how can I write this condition? Let us see. So this can be written as integration of 2x minus 3 whole power minus 4 plus 2 minus 3 by 7x power minus 6 dx. Now after converting into this form, again we apply the same method of integration according to the same formula. So let us see. So this we can write integration of, no need of any integration now, directly we write the answer now. So is equals to 2x minus 3 whole power minus 4 plus 1 divided by minus 4 plus 1 into 1 by the coefficient of x in this condition is 2. So 2 plus, now let us see the second one. So 2 minus 3 by 7x power minus 6 plus 1 divided by minus 6 plus 1 into 1 by, here the coefficient of x is minus 3 by 7. So minus 3 by 7 plus c. This is our answer. So you can further simplify this one. I am leaving up to here. So these are certain rules of integration. Now based on these rules and the formulae of trigonometric ratios, let us try to solve from some problems now. For example, first one, example integration of sine square x dx. Let us see how we can solve this one. So there is no direct formula of sine square x dx. We don't have any such formula. So let us see how we can convert to this one. According to trigonometric relations, we know that sine square x is equals to 1 minus cos 2x divided by 2. Therefore, same result we write here. So 1 minus cos 2x by 2 into dx. So 2 can be taken out of this integration. So 1 minus cos 2x dx. Therefore, half into, we can, so here there are two terms which are present. So we can apply integration to each of this term. So half into integration of 1 dx minus integration of cos 2x dx. So half into integration of 1 dx, we know it is equals to x, minus integration of cos 2x is sin 2x divided by 2 plus c. This is our answer. So let us see one more problem on this type of trigonometric relations. For example, if a question is given, integration of cos square x dx, then let us see how we can do this one. So in the case of trigonometric relations, again we have relation cos square x is equals to 1 plus cos 2x divided by 2. So just substitute this relation here. So 1 plus cos 2x divided by 2 into dx. Again we can take 2 out of this integration. So half into integration of 1 by 2 dx, 2 already we have taken out, 1 dx plus integration of cos 2x dx. So therefore again we will get half of integration of 1 dx is x plus integration of cos 2x is sin 2x by 2 plus c. This is our answer. So further we can simplify this one, that you can do. Let us see one more example. For example, integration is given like this, integration of tan square x dx. So in this condition also we don't have any direct formula of doing this relation. So how we can do, we have relation secant square x minus tan square x is equals to 1. Therefore, secant square x minus 1 is equals to tan square x. So let us try to substitute this relation here. So integration of secant square x minus 1 dx. So we can separate this one as integration of secant square x dx minus integration of 1 dx. So we know integration of secant square x is tan x. So tan x minus x plus c. So this is our answer. So let us see one more example of this one. So for example, a relation is given like this, integration of cot square x dx. So again, just in the previous model how we have solved, we can do this relation. So we know cosecant square x minus cot square x is equals to 1. Therefore, cosecant square x minus 1 is equals to cot square x. So therefore, if I substitute this relation, so integration of cosecant square x minus 1 into dx. So again you can take this differentiation to both of these terms. So cosecant square x dx minus integration of 1 dx. So integration of cosecant square x is minus cot x. So therefore it can be written as minus cot x minus x plus c. So this is the answer to our relation. So let us see if we can do some more examples. For example, let us integration of sin power 4x dx. So here also there is no direct integration formula here. So this sin power 4x can be written as sin square x whole square. Therefore, integration of sin square x whole square into dx. Now, sin square x can be written as 1 minus cos 2x divided by 2. Therefore, integration of sin square x whole square can be written as 1 minus cos 2x by 2 whole square into dx. Now this 1 by 2 we can take out of this integration. 1 by 2 whole square is 1 by 4. Integration of 1 minus cos 2x whole square into dx. Now this is in the form of a minus b whole square. Therefore, if we expand this relation, 1 by 4 into integration of a square minus 2ab plus b square cos square 2x into dx. So we have expanded this relation according to a minus b whole square here. So cos square x can be written as 1 plus cos 2x by 2. But here the given relation is the term which is present is cos square 2x. So this cos square 2x can also be written as 1 plus cos 4x divided by 2. Therefore, we write 1 by 4 integration of 1 square minus 2 cos 2x plus cos square 2x can be written as 1 plus cos of 4x by 2 into dx. Therefore, if I apply the rules of integration now, so integration of 1 dx will be x minus 2 into integration of cos 2x is sin 2x by 2. So sin 2x divided by 2 plus integration of 1 by 2 dx is 1 by 2 into x, and integration of cos 4x by 2 is equals to half into sin 4x divided by 4 plus c. So this is our answer to this problem. Now you can further simplify this one and you can get the answer. So this is how we can apply the rules of integration and the formulae of trigonometric ratios and solve the problems. Let us see one more example of this one. For example, the integration is given like this: integration of 1 by 1 minus cos 2x into dx. So this is of the form, let us see, sin square x is equals to 1 minus cos 2x divided by 2. Therefore, 1 minus cos 2x is equals to 2 sin square x. So let us substitute this one here. So integration of 1 by 1 minus cos 2x is equals to 2 sin square x. So 2 sin square x into dx. Now 2 I will take out. So integration of 1 by sin square x into dx. So 1 by sin theta can be written as cosecant theta. Therefore, this relation can be written as 1 by 2 into integration of cosecant square x into dx. Now we know there is a direct formula of integration of cosecant square into dx, which is called minus cot x. Therefore, we can write half into minus cot x plus c. That is the answer to this problem. Okay. So let us see one more example of this one. So let us suppose this is the given question: integration of square root of 1 plus sin x dx. So let us see how we can solve this problem. Solving problems can be obtained by experience. If we solve more number of problems, then the brain becomes more and more sharper. We get the proper ideas of solving the problem. So let us see how we can solve this problem. So 1 can be written as sin square x plus cos square x. Same 1 can be written as sin square 2x plus cos square 2x. Same 1 can be written as sin square x by 2 plus cos square x by 2 also. And sin 2x can be written as 2 sin x cos x, and sin x can be written as 2 sin x by 2 cos x by 2 also. Now if you see this relation and this relation, then we can say definitely this equation is in the form of sin theta plus cos theta whole square. Therefore, how can I write this relation? We can write integration of, instead of 1 I can write sin square x by 2 plus cos square x by 2, and instead of sin x I can write 2 sin x by 2 cos x by 2 into dx. Now definitely I can say this is in the form of sin A plus cos B whole square, sin A plus sin B whole square, cos B whole square. Therefore integration of, how can I write this one, square root of sin x by 2 plus cos x by 2 whole square into dx. So this square and this 2 gets root gets cancelled. So therefore integration of sin x by 2 plus cos x by 2 into dx. So now we have direct integration rules for this given functions. So we can write integration of sin x by 2 is minus cos x by 2 divided by 1 by 2, and integration of cos x by 2 is sin x by 2 divided by 1 by 2 plus c. So this is the answer to our problems. Now we are studying integration by substitution method. So substitution method in the sense, here if integrand is not present in direct form, then we take some part of this integrand, assume it with a new variable, and when you differentiate this new variable with respect to dx, then we should get the remaining part of the integrand. Then such type of solving the integration process, we call it as substitution method. Let us take one example. For example, the function which is given is integration of tan x dx. This is the function which is given. So this we can write it as integration of sin x by cos x dx. So in this condition, let us take some part of the integration. So let us consider, let cos x is equals to t in this condition. Now if I differentiate this cos x with respect to x, then let us see what I will get. So if I differentiate this one, I will get it as minus sin x, and again x we have to differentiate by chain method rule. So into dx is equals to dt. So therefore I will get sin x dx is equals to minus dt. So if you observe in this condition, cos x is the part of the integration we have taken. Cos x is equals to t. So if I have differentiated this one, then I got the remaining part of this integrand, which is sin x dx. So therefore I can substitute sin x dx is equals to minus dt, and cos x is equals to t, and I can solve this problem. So let us see what happens if I take this sin x to be t. So for example, if I take let sin x is equals to t. So if I differentiate this one, I will get cos x dx is equals to dt. But in the given condition, there is a dx by cos x. There is no term which is called cos x dx. So this method of solving is wrong. So definitely we have to consider cos x is equals to t. Then we have to differentiate this one so that I can get the remaining part of the function. So now let us see how we can do. So therefore integration of, instead of sin x dx, I can write it as minus dt. So instead of cos x, I can write it as t. So minus dt by t can also be written as minus of dt divided by t. So this is of the form of integration of 1 by x dx, which is called minus ln t. So therefore minus ln t. What is t value we have taken? T value is cos x plus c. So after this, what we can do? We can write the same function as ln of cos x power minus 1 plus c according to the rules of logarithms. So therefore this relation again can be written as ln of 1 by cos x plus c. So this can be written as ln of cos x is equals to 1 by cos x can be written as secant x plus c. So that is the answer to our problem. So let us see one more model in this condition. So for example, let us take one more problem. For example, the given problem is like this. Integration of ln x by x dx. So now which part of this integrand I have assumed with a new variable? That is a very important decision which we have to take. So let us consider 1 by x is equals to t here. Then if you differentiate this one, it will get minus 1 by x square dx is equals to dt. So this part of the term is not present in the integrand, so this method of assumption is wrong here. So let us take the other part which is present. So let ln x is equals to t. Then if you differentiate this one, I will get 1 by x dx is equals to dt. So this part is present in the integrand. So this must be our method of solving this problem. So therefore, how can I write it? Integration of, instead of ln x, I can write it as t, and instead of 1 by x dx, I can write it as dt. So integration of dt, this is what we can write. So integration of dt is t square by 2 plus c. So therefore, what is t we have taken? T we have taken as ln x whole square divided by 2 plus c. So that should be our answer. Similarly, let us take one more example. For example, the problem which is given is integration of 1 by x square e power 1 by x dx. So let this be the given condition. So here let us see how we can solve this problem. So let us take 1 by x is equals to t, then minus 1 by x square dx is equals to dt. So 1 by x square dx is equals to minus dt. Now if we substitute these results in the given problem, so integration of, so 1 by x square dx can be written as minus dt into e power 1 by x can be written as e power t. So this is the form of e power t into minus I can take here, so minus dt. So we know the result is, this is equals to minus of e power t plus c, and what is the t value we have taken? T value is 1 by x plus c. So this is our answer. So same problem, let us see if we can do in one more method. So let us do in a second method. For example, instead of taking this 1 by x is equals to t, so let us consider e power 1 by x is equals to t. Then if I differentiate this one, what I will get e power 1 by x, and by chain method, again I have to differentiate this 1 by x. So differentiation of 1 by x is minus 1 by x square into dx is equals to dt. So therefore, e power 1 by x into 1 by x square dx is equals to minus dt. So if you see in this problem, 1 by x square e power 1 by x dx, e power 1 by x e power 1 by x square dx, everything is present. So just we can substitute. So integration of, so instead of all this function, I can write minus dt, which is equals to minus t plus c. So minus t value which we have taken is e power 1 by x plus c. So this is the second method in which we can do this problem. So here we got e power minus e power 1 by x plus c, here also minus e power 1 by x plus c. So by this time you should have got an idea how to solve the problems by using substitution method. Very important method of solving the integration problems. So let us take one more problem. For example, let us take integration of secant square x divided by tan x dx. So now try to do this problem. You can pause this video and try to do this problem. Okay, now let us see. So by looking at the given conditions of this problem, definitely I can say I can take tan x is equals to t. Then differentiation of tan x is secant square x dx is equals to dt. So this is the part of the integrand which I have taken. When I differentiate this one, I got the remaining part of this integrand. So therefore, how can I substitute integration of secant square x dx is dt divided by tan x. So instead of tan x, I can write it as t. So again, this is the form of integration of 1 by x dx. So answer should be ln t plus c. So ln t is tan x plus c. So this is our problem. So we can check whether we have done correctly or not. How we can check this condition? Always you can differentiate the result, and if you are getting the initial function, then definitely we can say the method in which we have done is definitely correct. So try to differentiate this one and see if you can get this answer or not. Similarly, let us take one more example. For example, integration of sin square x into cos cube x dx. So here let us see how we can do this problem. So let sin x is equals to t. So differentiation of sin x is cos x dx is equals to dt. Then let us see how we can write this problem. This we can write it as integration of sin square x into cos square x into cos x dx. So sin square x can be written as t square. Cos x dx can be written as dt. Then what about this cos square x? So again we have relation sin square x plus cos square x is equals to 1. Therefore, cos square x is equals to 1 minus sin square x. So instead of cos square x, I can write it as 1 minus sin square x. So the relation converts like this: integration of sin square x into 1 minus sin square x into cos x dx. So let us see how we can do further. So in the terms of t and dt, let us see how we can write. Sin square x can be written as t square. 1 minus sin square x can be written as 1 minus t square. Cos x dx can be written as dt. So integration of t square minus t power 4 into dt. So integration of this, how we can do? So integration of t square, t cube by 3. Integration of t power 4 is t power 5 by 5 plus c. That is our answer. So t we have taken as sin x. So we can write sin cube x by 3 minus sin power 5x divided by 5 plus c. This is our answer. So let us take one more problem. For example, the given problem is integration of secant power 4x into tan x dx. This is our given problem. So let us see how we can do this problem. So let us take tan x is equals to t. Then if you differentiate tan x, we will get secant square x dx is equals to dt. So let us see how we can write this function. So integration of secant square x into tan x dx. So secant square x into dx can be written as dt. Tan x can be written as t. Then what about this secant square x? Then we have one more relation already we know. Secant square x minus tan square x is equals to 1. Therefore, secant square x is equals to 1 plus tan square x. Now we substitute this relation here. So secant square x can be written as 1 plus tan square x into secant square x into dx can be written as dt into tan x can be written as t. Therefore, the function can be written like this. So integration of 1 plus, instead of tan square x I can write it as t square dt into t. So integration of 1 plus t square into t dt. So integration of t plus t cube into dt. So we know that it's integration of t is t square by 2, integration of t cube is t power 4 by 4 plus c. So this is our answer. So therefore instead of t, what I can write, t was assumed as tan x was assumed as t. So tan square x by 2 plus tan power 4x divided by 4 plus c. So this is our answer. So same problem, let us see we can do in one more method. We have assumed tan x is equals to t here. So if I can assume secant x to be t, so then let us see if I can get the answer or not. So now we are assuming secant x to be t. Then let us see. So let secant x is equals to t in this condition. Then differentiation of secant x is secant x tan x dx is equals to dt. So now let us see how we can write this relation. I can write it as secant cube x into secant x tan x dx. Now I got the relation up to here. So secant x tan x can be written as dt and secant x can be written as t. So integration of secant cube x can be written as t cube into secant x tan x can be written as dt. So this is equals to integration of t cube is t power 4 by 4 plus c. So t value which we have assumed is secant x. So secant power 4x divided by 4 plus c. This is one more answer. So previous answer is also correct. This answer is also correct for this given relation. So in this method we can solve the problems by using substitution method. So some part of the integrand we assume with a new variable, and if I differentiate that one, then I should get the remaining part of the integration. So in this method we can solve the integration. So same results, we have some shortcut format and shortcut formulae. So if I can get the question in that format directly, I can write the answer. So let us see those shortcut formats also. For example, this is first type of format. So if I get a question like this, integration of f dash x divided by f of x dx. What is this f dash x and f of x? This is the given function, and f dash x is the derivative of this function f of x. So then the answer will become ln of f of x plus c. So this is our answer. So let us see one example of this one. So example, we can take the previous example which we have done, integration of secant square x divided by tan x dx. So tan x I can compare with f of x, secant square x I can compare with f dash x, the derivative of tan x is secant square x. Then the answer should be ln of f of x is nothing but tan x plus c. So let us see one more example. So integration of cot x dx. So cot x can be written as cos x divided by sin x dx. So check whether this is also present in the same format or not. Yes, definitely it is present. F of x I can consider as sin x. Differentiation of sin x is cos x dx. So definitely it is present in the format. So therefore it can be written as ln of sin x plus c. So this is our first format. Let us see the second one. Integration of f of x power n f dash of x dx. So if the function is present in this format, so f of x original function, f dash x the derivative of this function, and f of x is raised to the power of n here, then the answer should be f of x whole power n plus 1 divided by n plus 1 plus c. So this is one more format. So let us take an example. We can take the same example which we have taken previously, that is integration of secant power 4x tan x dx. So I leave this problem as an exercise to you. So try to see how this equation is fitting in the second format and try to get the answer of this one. Okay. So let us see one more format which is present, and that is integration of f dash x divided by square root of f of x dx. So if question is present in this type of format, then the answer which we can write is, so this is equals to 2 into square root of f of x plus c. So let us take an example. So integration of 2x plus 3 divided by square root of x square plus 3x plus 7. So this is the given function square root of x square plus 3x plus 7, and if I differentiate this one, then definitely I will get 2x plus 3. So this is present in the same format. So therefore answer should be 2 into square root of f of x is nothing but x square plus 3x plus 7 plus c. That is our answer. Similarly, we have some more direct equations, direct formulae. Let us see them also. For example, fourth one. So integration of 1 by x square plus a square dx. Then the formula of this one is 1 by a tan inverse of x by a. So this is our answer. Let us take an example. Integration of 1 by 5x square plus 7. So this I can write it as integration of, I can take a 5 common, then it will become x square plus 7 by 5 dx. Now I can take this 1 by 5 outside the integration. Integration of 1 by x square plus 7 by 5 can be written as root of 7 by 5 whole square into dx. Now if you see carefully, this function is exactly fitting in this format. So therefore the answer should be 1 by 5 into 1 by a value is root 7 by 5 into tan inverse of x. What is x value? X value is x itself divided by a value is root 7 by 5 plus c. So if we want to simplify it further, we can simplify like this. So this root 5 goes to the numerator, and here we have 5 which can be written as root 5 into root 5. So this root 5 and this root 5 gets cancelled. So I will get a root 5 by 7 tan inverse of. So root 5 sorry. So here we will get 1 by root of 7 5s are 35 tan inverse of, and this root 5 goes to the numerator, root 5x divided by root 7 plus c. So that is our answer. So let us see the next format. Fifth one. So integration of 1 by x square minus a square dx. So this can be written as 1 by 2a ln x minus a divided by x plus a plus c. Sixth one. Integration of 1 by a square minus x square dx, and the answer to this one is 1 by 2a ln a plus x divided by a minus x plus c. So you should be careful with these two formulae, they are a bit confusing. So once if you see it carefully, you can understand this relation. So let us see one more example which fits in these formats which we have discussed now. For example, a function is given like this. Integration of 1 by x square plus 20x plus 7 dx. So if this type of functions are given, first of all we should try to convert this function into a perfect square. So let us see what is the method of converting this one into a perfect square. Take this 20x term, take this 20. What is this 20? The coefficient of x is 20 here. Divide this 1 by 2, then you will get 10, and take the square of this 10, which is called 100. So this is the method in which we have to do. Then the same relation I can write like this also. Integration of 1 by x square plus 20x plus, now add this 100, similarly subtract this 100 plus 7 into dx. Okay. Now after this step, let us see how we can convert this one into a perfect square. So same problem I can write like this, 1 by, so x square plus 20x can be written as 2 into 10x, 100 can be written as 10 square, minus 100 plus 7 is minus 93 into dx. So integration of 1 by, so this is of the form of x plus 10 whole square minus 93. The same can also be written as integration of 1 by x plus 10 whole square minus root 93 whole square. We can write like this also. Now if you observe this relation, this is exactly of the form of integration of 1 by x square minus a square, which is equals to 1 by 2a, 2 into a value here is root 93 ln x minus a, so here x value is x plus 10 minus a value is root 93 divided by x plus a, here x value is again 10 plus root 93 plus C. This is our answer. So this is the method of substitution and direct formats which we have studied. In the next lecture, we will study how we can use this integration in real life to calculate the different functions which are present in our life. Thank you. Dear students, today we will study some of the applications of integration. Let us see how integration is used in physics for calculating different conditions. Let us see. So, applications of integration. So first one, let us see how we can calculate area of a rectangle. For example, if this is the rectangle which is given, whose length is L and breadth is B, then definitely we can say area is equals to L into B. So same formula we have to prove with the help of integration. Let us see how integration can be used and we can calculate the same formula. So here we take a small elemental strip at a distance of x and whose width is dx. So always we consider the shape of the elemental strip such that if we place a number of strips, then it should cover the total area of the body which is given. So this is the shape of the strip which we are taking here. So therefore, if I calculate the area of this elemental strip, then I can write dA is equals to, see what is the length of this one, I can write length is B and breadth is dx. So therefore I can write B into dx. Now if I want the total area of this rectangle which is given, then I have to place many number of strips one beside the other one and I have to add the area of all these elemental strips. So addition of all the elemental strips is nothing but integration. That's what we have studied in the previous lectures. So therefore, if I integrate this on both sides, and the limits of integration should be from 0 to L. So here length of this rectangle is 0, and when I start moving in this direction, its length increases and final length of this rectangle becomes L in this condition. So therefore, the limits of integration should be 0 to L. So integration of dA is A. So integration of 0 to L B into dx. So A is equals to B is a constant. So integration of 0 to L B into dx. So therefore, A is equals to B into integration of dx is x and the limits are applied from 0 to L. So therefore, A is equals to B into L, which is called L into B. So this is our answer. So in this method, we can calculate the area of this rectangle. So let us see one more application of this one. So area under any graph. So if a curve is given or any graph is given, then how can I calculate its area? Let us see. For example, if this is the given graph, y-axis and x-axis, and if this is a linear graph and x limits are from x1 and x2, then definitely I can say area in this condition is x2 minus x1 into y. So this will become my area. So instead of giving the area like this, if the given graph is in this form, so graph is like this, then in this condition directly I cannot get area of this graph. So here I can say this y, it depends on the value of x. Y is not a constant, it is continuously changing with respect to x. So therefore here I can write y is a function of x. Then in this condition what I can do is, again I will take a very small strip at a distance of x and whose width is dx. So at this condition, let the y value is y. Now, how can I calculate area of this small elemental strip? So, area of this small elemental strip, which is called dA, can be written as, so thickness of this one is dx and length of this one is y. So therefore, dA is equals to dy into x. That becomes the area of this small elemental strip. Similarly, if I want the total area under this graph, then I have to all these kinds of elemental strips. Then that should give the total area under this graph. So this total summing up is nothing but integration in this condition. And the limits of integration are applied from x1 to x2. So that is, the graph is present from the initial limit of x1 to the final limit of x2. So therefore, my limits of integration will become from x1 to x2. So therefore, the answer will become integration of y dx x1 to x2, and this is my answer. Similarly, y, if it is given in the form of a function, then I can write y is equals to f of x dx x1 to x2. So this should give the area under the graph. So let us try to understand this one with the help of a small example. For example, y is varying with respect to x as 2x square plus 3x. So this is the given function. Then I am supposed to find out the area under this graph when x varies from 1 to 2. Then how can I calculate the area? So a is equals to integration of f of x dx, and the limits of integration are applied from 1 to 2. So therefore, integration of 1 to 2, f of x in this condition is 2x square plus 3x into dx. So therefore, a is equals to integration of 2x square will become 2x cubed by 3 plus 3x square divided by 2, and the limits of integration are from 1 to 2. So therefore, first we apply the upper limit, then we apply the lower limit, and we solve the area. So therefore, 2 into 2 cubed by 3 plus 3 into 2 squared by 2 minus, now we apply the lower limit, 2 into 1 cubed by 3 minus, next term is plus 3 into 1 square divided by 2. So if we solve this condition, that should give the area under the graph. So I hope you can solve this question. Okay, so this is how we calculate area under any graph. Now let us see one more application of integration, that is center of mass of uniform rod. So for example, this is a uniform rod of length L and mass of this rod is m. Then definitely I can say center of mass of this uniform rod should lie at the center of this rod at a distance of L by 2 if I am taking this point as the reference point. This I can understand. Now with the help of integration, we have to prove that this center of mass lies exactly at the point of L by 2. So in the chapter of center of mass, we get this formula which we will study in the next lectures. X center of mass is equals to 1 by m integration of x dm. So this is the formula for center of mass. If center of mass is lying only on one axis, here definitely I can say this is a very thin rod, therefore center of mass must lie on x axis only. So x center of mass is equals to 1 by m integration of x dm. So here we are supposed to find out integration of x, but with respect to dm. So let us see how we can modify this dm in this condition. So in this rod, we take a small elemental mass dm whose width is dx. So or we can take whose width is dl. Then how can I write dm? The very small mass present in this small strip which we have taken, dm can be written as dl divided by L into capital M. So try to understand what is this dl by L. dl by L will become the fraction of length. So dl is a very small length, L becomes the total length of this rod. So dl by L is the fractional length which we have taken. And when this is a fractional length, if you multiply by the total mass, it will give the fractional mass in which is present in this small strip. So dm is equals to dl by L into m. Now if I substitute in this equation, then I will get x center of mass is equals to 1 by m integration of x. Instead of dm, I can write dl by L into capital M. So x center of mass is equals to this m and this m gets cancelled. L is a constant, I can take it out. Integration of x into dl. So this is at a distance of x and this is dl, and the limits of integration should be from 0 to L. So therefore, x center of mass, for confusion you can write it as small l also to remove the confusion, or you can calculate, you can assume this value as small l, and this small length will become dl. So x center of mass is equals to 1 by L. Integration of L will become small l squared by 2 when the limits are applied from 0 to capital L. So therefore, x center of mass is equals to 1 by L into L square divided by 2. So this L and square gets cancelled. So L by 2 is our answer. So this is how we can apply integration and calculate the center of mass of any bodies also. Let us see one more application of this one. For example, if I want to calculate area of a circle. So this is a circle of radius r. Then I know area is given by pi r square. Now the same formula we are supposed to derive by using the condition of integration. So how to apply integration here? So again we have to take a small elemental strip such that if I add all these elemental strip, then I should get the total shape and size of this body which we have taken. So therefore I will consider a very small circle, or I will consider a very small ring of radius small r, and the thickness of this ring I will take it as dr. Therefore, how can I calculate area of this elemental ring? Area of this elemental ring dA can be calculated as 2 pi r into dr. So 2 pi r gives the circumference of this ring, circumference of this ring, and dr gives the thickness of this one. So this is a length, this is also a length, length into length will give area. So now I want to calculate total area of this circle which we have taken. Then obviously we know that we have to integrate on both sides. So integration of dA is equals to integration of 2 pi r dr. And the limits of integration should vary from 0 to capital R. That is, here we take a very small ring, we take the next ring, next ring, next ring like this. So length of, this elemental strip of radius 0 to elemental strip of radius capital R. If I add all these areas of these rings, then I will get the total area of this ring. Therefore, limits of integration are from 0 to capital R. So integration and differentiation gets cancelled. So A is equals to, here 2 pi is a constant. So integration of r, and when limits are applied from 0 to r with respect to dr. So A is equals to 2 pi into r square by 2, and the limits are applied from 0 to capital R. So A is equals to 2 pi into capital R square by 2. So this 2 and 2 gets cancelled. So pi r square is our answer. So in this method, we can calculate area of a circle by using the concept of integration. Now let us see one more example. Let us try to calculate area of a triangle with the help of the concept of integration. So area of a triangle. So if this is the given triangle of base B and height h, then definitely I can say area is equals to half into base into height. So now I want to prove this formula by using the concept of integration. Let us see how we can do this one. So in this triangle, I take a very small strip of length x, and which is at a distance of y, and whose thickness is dy. Then how can I write area of this small elemental strip? Area can be written as length into breadth. Length is x, breadth is dy. So this is my equation number 1. So in this area, this x is my assumed value, so which I cannot put it in the final answer. So let us try to derive this x value in terms of remaining given conditions of this triangle. So if you see this small triangle and this bigger triangle, then these two triangles are similar triangles. Then in the case of similar triangles, how can I write a relation between the sides of both the triangles? I can write it as x by y is equals to b divided by h. So the ratio of x by y and the ratio of b by h must be equal. So therefore x is equals to y into b divided by h. So this is our equation number 2. So substituting 2 in equation number 1, let us see what happens. So therefore dA is equals to, dA is the area of this small elemental strip. So x, instead of x, what can I write? I can write y into b by h into dy. So this becomes the area of my small elemental strip now. Now I want to calculate total area of this triangle. So we have to integrate on both sides. So A is equals to integration y into b by h into dy. Now the limits of integration are from 0 to h. That is, we have taken this strip, place one strip above this one strip below this one. So fill this total triangle with all the strips which we have taken. That is, integration should be done from 0 to h, if this we are taking as the reference point. So therefore integration limits are from 0 to h. So A is equals to, in this condition b by h should be a constant. So b by h, I take it out, integration 0 to h y dy. So A is equals to b by h into integration of y is y square by 2, and the limits are applied from 0 to h. Therefore A is equals to b by h into h square divided by 2. So this h and square gets cancelled. The result is half into base into height. So therefore by using the concept of integration, we have calculated area of a triangle also. So let us see some more applications. Now let us try to calculate area of a sphere with the help of integration. So area of a sphere means surface area of a sphere. Sphere or shell, whatever it may be, surface area always remains same. So this is a sphere of radius r, then definitely I can say its surface area should be 4 pi r square. Then this formula I have to prove now with the help of integration. So how to take elemental strip for calculating surface area of a sphere? What I can do is, on the surface of the sphere, I can take an elemental ring like this. That is, if I place one ring above this one ring below this one, continuously I fill this total area with the help of elemental rings, and if I add the areas of all these rings, then I should get the total surface area of the sphere. So this is what I am trying to do now. So from here, this is the radius r, and area or radius of this small ring I can take it as small r, and the thickness of this ring I consider as dl. So these are my assumed conditions. So therefore, how can I calculate one more condition which is present is, so this ring is at an angle of theta, and this elemental ring is making an angle of d theta. So these are the different conditions we have taken. So this ring is having a radius of small r, ring is at an angle of theta from the center of this sphere, and this elemental ring is making an angle of d theta. Therefore, how can I calculate area of elemental ring? Area of elemental ring can be calculated by length into breadth. Length is nothing but circumference of this one, which is called 2 pi r, and breadth is the thickness of this one, which is called as dl. Now this r is also an assumed value. So let us see how can I calculate this r value. So capital R is like this, small r is like this. This is angle theta. If this is angle theta, this also becomes angle theta. Then if I try to write it in the form of a triangle, then this is the triangle which is formed. So if I can split this r value into rectangular components, then r can be written as r cos theta, and this side will become r sin theta. So this splitting of vectors we will study in the topic of vectors. Now we have got the relation r is equals to r cos theta. So this is our equation number 1. Similarly, here we have dl, that is the thickness of this ring. Now let us try to write this dl in terms of theta. Then we know the relation theta is equals to L by R in the form of an arc. So if I take a small arc, then the angle made by the arc is length of the arc divided by radius of that circle. So therefore I can write d theta is equals to dl divided by capital R. Therefore dl is equals to d theta into R. So this is my equation number 2. So let us call it as equation number 0. So now substituting 1 and 2 in equation number 0. Then how can I write? Elemental area dA is equals to 2 pi into, instead of R, what can I write? Instead of R I can write R cos theta, and instead of dl I can write R into d theta. So dA is equals to 2 pi R square cos theta into d theta. So I hope you have understood up to here how we have calculated the different conditions. So this dA is the area of this elemental strip. Now I want to calculate the total surface area of this strip. Then definitely what we can do, we have to integrate. So therefore A is equals to integration limits. Now what are the limits? So this angle theta has been taken from this reference. So therefore we have to integrate it to totally from here and here also. That is, if I take from here to here as capital R, plus R, then here to here it should become minus R. It means the limits of integration are applied from minus R to plus R. So therefore, integration limits are from minus R to plus R, 2 pi R square. Sorry, so we are not considering in terms of minus R and plus R. We are taking angle theta here. So angle will become minus pi by 2 to plus pi by 2. If I take this point as the point of reference, so the limits of integration are from minus pi by 2 to plus pi by 2, 2 pi R square cos theta into d theta. So here 2 pi R square is a constant, so I can take it outside. So A is equals to 2 pi R square, and integration of cos theta is sin theta, and the limits are applied from minus pi by 2 to plus pi by 2. So therefore, after this if I say, so area is equals to 2 pi R square into sin plus pi by 2 is plus 1, minus of sin minus pi by 2 is minus 1. So therefore the area is equals to 2 pi R square into 2, which is called 4 pi R square. So this is how we can calculate surface area of a sphere. So I hope you have understood the different conditions, how we have calculated. Similarly, let us see some of the applications, some more applications. Now if I want to calculate volume of a sphere, okay, so for example, this is a sphere of radius r, then I know volume is equals to 4 by 3 pi r. So this volume of a sphere I want to calculate with the help of integration. So how can I take elemental strip? So volume in the sense, I have to take total space which is covered by the sphere that I want to calculate. So what I do is, I take a small elemental disk like this, and this elemental disk is at a distance of x from the center, and width of this elemental disk I can call it as dx. This width is dx, and radius of this disk is small r. So these are the different conditions. I have taken a small elemental disk. So my purpose is that on this disk I place another disk, on this below this disk I place one more disk. So continuously I fill this total volume with the help of disks, and if I can calculate volume of all these disks, then I will get the total volume of this sphere. Then volume of elemental disk, how can I calculate? dV is equal volume, length into breadth into height, or I can say area into thickness. So area of this disk is pi r square, and the thickness of this disk is dx. Sorry, pi small r square, and thickness of this disk is dx. So this r is my assumed value. Similarly, dx is also an assumed value. So therefore, see what is the construction which is present here. This is r, this is x, and this is a small r. Then definitely I can write r square is equals to x square equals to pi into pi I am taking outside, integration of r square minus x square into dx. Now the question is, what are the limits of integration in this condition? So here we have not taken any angle. We are solving with respect to x in this condition. That is, we have to integrate it from 0 to plus r and similarly 0 to minus r also. So therefore the limits of integration will become minus r to plus r. So therefore v is equals to pi into integration of r square will become, r square is a constant, so r square into x minus x cube by 3. So this is our integration, and the limits are applied from minus r to plus r. So therefore v is equals to pi into, now if I substitute the upper limit, it will become r cube minus r cube divided by 3 minus of, now I substitute the lower limit, r square into minus r minus of minus r whole cube divided by 3. So this is my lower limit. So v is equals to pi into, so this will become 2r cube by 3. So this will become minus of, so this is r cube, this is plus r cube by 3. So minus of 2r cube divided by 3. Therefore if I solve this one, v is equals to pi into 2r cube by 3 plus 2r cube by 3. So v is equals to 4 by 3 pi r cube. So this is my answer. So I hope you have understood how we calculated this volume of a sphere. Now let us see one more condition. One more application we see, which is very important in understanding the concept of integration. Volume of a cone. So this is a cone of radius capital R, and it is having a height of small h. Then we know volume of a cone is v is equals to 1 by 3 pi r square into h. So this same relation I want to calculate with the help of integration. So let us see how we can calculate. So here also I take a small elemental disk, so which is at a height of y from the vertex, and which is having a thickness of dy, and which is having a small radius of r. Now in the case of these assumed conditions, how can I calculate volume of this small elemental disk? So volume of elemental disk, dv is equals to, volume is area into thickness, so area is nothing but pi r square into thickness is dy. So let it be equation number 1. So pi r square into dy. So this r is our assumed value. So I want to write this r value in terms of the given conditions, that is height of this cone and radius of this cone. So how can I write? Again we use the concept of similarity here. So this cone, smaller cone and bigger cone, these two are similar cones. Therefore how can I write a relation between them? I can write r by y is equals to r by h. So the ratio of r by y should be equal to the ratio of r divided by h. So therefore r can be written as r by h into y. So this is our equation number 2. Now let us try to substitute this equation number 2 in equation number 1. So if I try to substitute, dv is equals to pi into, instead of r square I can write r square by h square into y square into dy. So up to here I got. Now I want to calculate total volume of this cone. Then I have to apply integration, and the limits of integration, I hope you should have understood by until now what is meant by the limit of integration. So the limits of integration are from 0 to h. So So V is equals to, so in this see what are the constants which are present. Pi is a constant, r square is a constant, h square is a constant, and integration of y square dy, limits are applied from 0 to h. So V is equals to pi r square by h square into y cube divided by 3, limits are applied from 0 to h. So therefore V is equals to pi r square by h square into 1 by 3 into h cube. So therefore this h square and cube gets cancelled. Then see what are the remaining terms which are present. 1 by 3 pi r square h. So is equals to 1 by 3 pi r square into h. So this is how we can calculate volume of this cone also. So I hope I have covered most of the topics of integration which are useful in solving the problems of physics. So we will stop integration up to here. In the next lecture we try to understand the concept of trigonometry, different angles, how we can find out, and if there are any shortcuts in this trigonometry we try to understand. Thank you. Dear students, today we shall see the concept of trigonometry. So most of the students have small confusions about the application of trigonometry, how to find out the values of different angles also. So that we are going to discuss today. So before going into the main topic, let us first understand about angle. So for example, a body is moving in a circular path. It is starting from point A and it has reached to point B in this direction. Then I can say the angle covered by this person is theta, and this theta I can call it as angle or angular displacement. So if a person has started from point A, it has traveled throughout this circle and it has reached the same point again, then I say that this person has covered an angle of 2 pi radians, or we can also say the person has covered 360 degrees. So this radians, this is the SI unit of measuring the angular displacement. So for one complete rotation it is equals to 2 pi radians, or also we can call it as 360 degrees also. Therefore 2 pi radians should be equal to 360 degrees. We can also write this one as 2 pi into 1 radian is equals to 360 degrees. Therefore 1 radian should be equal to 360 divided by 2 pi. Also I can write it as 360 divided by 2 into 3.14. So 360 divided by 6.28. This should be equal to 57.3 degrees. Therefore 1 radian in terms of degrees is equals to 57.3 degrees. So this is the relation between radians and degrees. So after this, let us try to understand what is meant by quadrant system. So if I take a coordinate system, then this becomes plus x, this is minus x, this is plus y, and this is minus y. So if I take any point on this coordinate system, then the position of this point will depend on different values of these x and y values. For example, if I take this point, point A, then here the coordinates will be in terms of plus x and plus y. So I can write plus x comma plus y. If I take this point, point B, then here the coordinates should be minus x and plus y. So minus x and plus y. Here if I take a point C, then the coordinates should be minus x and minus y. And if I take another point D, then the here coordinate should be plus x and minus y. So depending on the position of this point, we can say what are the symbols of this plus and x values. So if a person has covered a total angle of 360 degrees, then I can say the total angle covered in this condition is equals to 2 pi radians or 360 degrees. So same here I can say this amount of 1/4 of this circle, the angle which is covered here should be equal to 90 degrees if I start from here. So this I can call it as first quadrant, this I can call it as second quadrant, this should be third quadrant, and this should be fourth quadrant. So if I take this angle as 0 degrees, then it should be 90 degrees, this should be 180 degrees, this should be 270 degrees, and this should be 360 degrees, or also I can call it as 0 degrees also, because after one complete rotation again it has started the same point. In terms of radians, I can call it as this is 0 radians, this is pi by 2 radians, this is equals to pi radians, this is equals to 3 pi by 2 radians, and this is equals to 2 pi radians, or again I can call it as 0 radians. So this is the coordinate system which we can understand. Now in this, after studying this coordinate system, let us try to understand what is meant by a right angled triangle. For example, if I consider this as a right angled triangle, so if I am taking this angle as theta, then this side will become adjacent side, this side will become opposite side to this angle theta, and the longest side will become the hypotenuse. Now different ratios of these different sides are just called as trigonometric ratios. For example, if I take a sine theta, then this is the ratio of opposite side to hypotenuse. If I take cos theta, it is the ratio of adjacent side divided by hypotenuse. Tan theta, it is called sin theta divided by cos theta, also can be written as opposite side divided by adjacent side. After this we can study about cosecant theta, which is the reciprocal of sin theta, also can be called as hypotenuse divided by opposite side. Similarly, we have secant theta, which is the reciprocal of cos theta, so this can be written as hypotenuse divided by adjacent side. And finally we have tan theta, cot theta, which is the reciprocal of tan theta, and this can be written as adjacent side divided by opposite side. So these are the different trigonometric ratios which are present. Now let us see with respect to quadrant system how these trigonometric ratios will change when this angle also changes, which is a very important observation for understanding these trigonometric ratios. So let us see them. For example, I take a circle and I divide this circle into 4 quadrants. Then let us suppose a body is present here and it is making an angle of theta with respect to the horizontal. So this vector I can call it as a radius vector if it is having a particular direction. Then this radius vector, always I can split this one into 2 components. One is called opposite component and another one is called adjacent component. So this splitting is according to the rectangular components of vectors. Splitting of vectors we will study in the next chapter. So this becomes the opposite side and this side becomes the adjacent side and this becomes the hypotenuse. So for this angle theta, this is the opposite side and this is the adjacent side. Now this person which was previously present at point A, now it has moved from point A to point B in this direction. Then the new angle which is formed is this angle. So if this is theta 1 and this is theta 2, then I can say the total angle created is theta 1 plus theta 2 in this condition. Now to this new angle which is created, now this becomes the opposite side and this becomes the adjacent side. So when you observe carefully this first angle and the second angle, then we observe that the length of the opposite side has increased and length of the adjacent side has decreased. So therefore we can write opposite side length has increased, adjacent side length has decreased, hypotenuse is remaining constant. So this is a very important observation in this condition. So here angle theta is also increasing, opposite side is increasing, adjacent side is decreasing, hypotenuse is remaining constant. Then what is the effect of these sides on these trigonometric ratios? Let us see. So we will study these three ratios and let us see if I can study about the changes in these three ratios, then definitely I can understand what is the change that is going to happen in the remaining three trigonometric ratios also. So sin theta is equals to opposite side divided by hypotenuse. Opposite side is increasing and hypotenuse is remaining constant. So definitely I can say sin theta value increases. Similarly, cos theta is the ratio of adjacent side divided by hypotenuse. Adjacent side length is decreasing, hypotenuse is remaining constant. So therefore I can say cos theta value is decreasing. And if you take tan theta is the ratio of sin theta divided by cos theta. Sin theta is increasing, cos theta is decreasing. So that is numerator is increasing and the denominator is decreasing. So definitely I can say tan theta is increasing by much greater value when compared to sin theta. So this is how the changes are happening when we are moving from 0 to an angle of 90. So sin theta is increasing, cos theta is decreasing, tan theta is increasing to a greater extent. Now is the same condition applied for all this rotation or only for a particular rotation? That we are trying to discuss here. So when I continuously move from 0 and if I reach this 90 degrees angle, this total angle when it becomes 90 degrees, then what I observe is hypotenuse is always a constant. Then the length of this opposite side continuously increases and at an angle of 90 degrees definitely I can say at 90 degrees what happens is hypotenuse will become equal to opposite side and this adjacent side length is continuously decreasing, and when the angle has reached 90 degrees this adjacent side length has become equal to 0. So this is what is happening from 0 to 90. When the body has reached 90 degrees, then the length of hypotenuse and the length of opposite side they have become equal and adjacent side length has become 0. Now again if I take sin theta, it is equals to opposite side divided by hypotenuse. So length of both of them has become equal, so therefore I can write it is equal to 1. So therefore I can say sin 90 degrees is equals to 1. So this is how basically we have derived the values of different trigonometric ratios for different angles. Similarly, if I study about cos theta is equals to adjacent divided by hypotenuse. Adjacent side length has become 0 at an angle of 90 degrees. So 0 divided by hypotenuse is also a 0. So therefore I can say cos 90 value has become equal to 0. Then what about tan 90? Tan 90 is equals to sin 90 divided by cos 90. So sin 90 value is 1, cos 90 value is 0. So this is infinite, or we can say this is undefined. So this is how the values change from 0 to 90 degrees. Now let us try to understand what is happening if the body further moves from 90 to 180 degrees. Let us see that discussion also. So when the body has come up to here, so let us call it as position C, and it has again further rotated and it has reached a point D now. Now if you draw there opposite sides, adjacent side, opposite side and adjacent side, then the thing which we understand here is the length of opposite side is decreasing and the length of adjacent side is increasing. So definitely I can say sin theta value decreases and cos theta value increases. And now when this radius vector is present on this angle at an angle of 180 degrees. So at 180 degrees what is happening? hypotenuse has become equal to what is this side? Adjacent side. It has become equal to adjacent side. And what about opposite side? Opposite side has become equal to 0. So therefore, again if I write the values of sine theta and cos theta at an angle of 180 degrees, then sine 180 is equals to opposite divided by hypotenuse. Opposite has become 0 and hypotenuse, the total value is 0. Cos 180 is equals to adjacent divided by hypotenuse. So at an angle of 180 degrees, the adjacent side and the hypotenuse values have become equal. So this is equals to 1. But if you see in this condition, so this adjacent side is present on minus x-axis. So therefore I can write it as minus 1. And hypotenuse is always taken to be positive itself. So let us see why we are taking hypotenuse always to be positive and how we are getting these values. So I hope now we have understood how these sine theta and cos theta values are changing. Okay, so let us continue our discussion. So for example, let us take a coordinate system. So first quadrant, second one, third one and fourth one. So this is the right angle triangle which is present. This is angle theta. So this is adjacent side, this is opposite side and this is hypotenuse. So according to Pythagoras theorem, how can I write hypotenuse? Hypotenuse side square is equals to opposite side square plus adjacent side square. So this is how I can write. So if it doesn't depend on whether opposite side is positive or negative and adjacent side is positive or negative. So because we are taking the square of these values, I can say always hypotenuse value should be positive itself. So therefore in the first quadrant, if I call this as the first quadrant, so in this first quadrant, adjacent side is positive, opposite side is also positive, hypotenuse is also a positive. So therefore I can say every trigonometric ratio should be positive in the first quadrant. So I represent this one by all. It means that all the trigonometric ratios are positive in the first quadrant. Similarly, if I go on to the second quadrant like this, then this is my adjacent side, opposite side, and this is my hypotenuse. Just now we have discussed that hypotenuse is always a positive value. In this condition, this adjacent side is lying on negative x-axis. So here this adjacent side is negative and this opposite side is lying on the positive y-axis. So therefore this is positive. So adjacent side is negative, opposite side is positive, hypotenuse is also positive. Then here, what is the ratio of opposite by hypotenuse, which is called sine theta? So sine theta should be positive. Similarly, the reciprocal of sine theta is called as cosecant theta, and this cosecant theta also should be positive. So these two will be positive in the second quadrant. Now, if I draw the same type of diagram here like this, then again here I can say here opposite side is negative, adjacent side is negative, hypotenuse is always positive. So therefore, if I take the ratio of adjacent and opposite, then tan theta is equals to negative of negative will become positive. So therefore, tan theta is positive in the third quadrant, and the reciprocal of tan theta is cot theta. So therefore, cot theta is also positive in the third quadrant. Now, if I take the radius vector in the fourth quadrant, then this is how I can draw the diagram. So this is negative opposite side, this is positive adjacent side, this is also positive. So therefore, if I take cos theta, which is the ratio of adjacent side divided by hypotenuse, then here adjacent side is positive, hypotenuse is also positive. So therefore I can say its total value will be positive. Similarly, the reciprocal of cos theta is secant theta, and this is also positive. So instead of these values, remaining all the trigonometric ratios will become negative. So this is the basic reason why we say some of the trigonometric ratios are positive and some of the trigonometric ratios are negative in different quadrants. Okay. So this is represented by a short method which is called all silver, and in the third quadrant we write it as T, and here we call it as cups. All silver T cups. So this is one method of remembering which trigonometric ratio is positive and which of them are negative in different quadrants. All represents that all the trigonometric ratios are positive in the first quadrant. Silver represents only sin theta. So sin theta and reciprocal of sin theta is cos theta. These two are positive here. T represents tan theta. Reciprocal of tan theta is cot theta. So these two are positive in the third quadrant. And C represents cups. The first letter of cups, C represents cos theta, and reciprocal sin the secant theta are positive in the fourth quadrant. So this is how we can explain how these trigonometric ratios are changing and why some of the trigonometric ratios are positive and why remaining are negative. Okay. So after studying this one, now we have to study the values of these trigonometric ratios for different angles. So for each angle we have a different value, but generally we study only some of the values of these trigonometric ratios. So let us see those values. So this is a general table which we should have studied in the lower sections. So sin, cos, tan, cosecant, secant and cot. So angles are 0, 30, 45 degrees, 60 degrees and 90 degrees. So if I can remember the values of sin theta, then remaining all the values we can derive from the same values of sin theta itself. So let us see. So values of sin theta for different angles are 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. So just you take the reciprocal from the back side of all these angles, then I will get cos theta. So from the back side if I start, then 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. Then how about tan theta? The ratio of sin theta by cos theta is nothing but tan theta. So 0 by 1, 0, division of these two will give 1 by root 3. Here I will get 1, here I will get root 3 and 1 by 0 is indefinite. Similarly, cosecant theta, reciprocal of sin theta is nothing but cosecant theta. So 1 by 0, indefinite. 1 by root 2 is 2, then root 2, then 2 by root 3 and 1 by 1 is 1. Then secant theta, reciprocal of cos theta is nothing but secant theta. So 1, 2 by root 3, then root 2, then 2, then indefinite. 1 by 0 is indefinite. Similarly, cot theta, reciprocal of tan theta, I can write it as cot theta. So 1 by 0, indefinite. So this is root 3, this is 1 by root 3 and this is 1 by indefinite. Indefinite means this is a very large value, so 1 by very large value will become 0. So these are the different trigonometric ratios which we have to remember. Similarly, while solving the problems of physics, like when we solve Newton's laws of motion, then there are very two important angles which we have to learn their values also. They are sin 37 is equals to 3 by 5, cos 37 is equals to 4 by 5. Next we have sin 53 is equals to 4 by 5, cos 53 is equals to 3 by 5. Similarly, tan 37 is equals to 3 by 4, take the ratio of these two, 3 by 4. Tan 53 is equals to 4 by 3. So these values are also very important values. We are asked extensively questions on these angles also. Okay. So if these angles are given, then we can directly substitute these values and we can get the answers. So instead of these angles, if any other angle is given, then let us see how we can solve those values also. For example, if a question is given, find out the value of sin 120 degrees. Then if any angle greater than 90 degrees is given, then always we split the angles in terms of 90 and 270, or we can split in terms of 180 and 360 degrees. So if we can split the angle in terms of 90 and 270, then sin converts into cos, tan converts into cot, and cot converts into tan. Similarly, cos converts into sin, and secant can be converted into cosecant, and cosecant can be converted into secant. Similarly, if I can split the angle in terms of 180 degrees or 360 degrees, then no change in trigonometric function. So let us take an example of this sine 120 and let us see how we can solve this problem. So sine 120 degrees, we can write this angle in two methods. So I can write it as sine 90 plus 30. Also I can write it as sine 180 minus 60 degrees also. So here we have written this angle in terms of 90, then what we have discussed here, then sine converts into cos. Then I can write it as cos 30. Similarly here we have written this one in terms of 180, then there should not be any change in the trigonometric ratio. Then here I can write it as sine 60. So cos 60 value is root 3 by 2, sine 60 value is also root 3 by 2. So we have solved up to here. So these are the values which we got. Now we have to check whether these values are positive or negative. So we go for this angle 120 and check whether this angle given is present in which quadrant. Then in that quadrant again we have to check whether this sine theta, the given trigonometric function, if it is positive or negative. So if you see this angle, this 120 degrees is present in second quadrant and the given trigonometric function ratio is sine theta, and we have to check whether this sine theta is positive or negative in the second quadrant. So we know that sine theta is always positive in the second quadrant. So therefore this is positive and this is also positive. So in this method very easily we can get the value of any trigonometric angle. Let us see some more examples of this one. For example, given function is, given trigonometric ratio is sine 150, then this one can be written in two methods. We can write it as sine 90 plus 60. Similarly, we can write it as sine 180 minus 30. So sine 90 plus 30, because we have written this one in terms of 90 and 270, it converts into cos 60, and this converts into sine 30 itself. Cos 60 value is 1 by 2, sine 30 value is 1 by 2. So values we got up to here. Now the question is whether they are positive or negative again. Again we go for this angle 150, it is present in second quadrant, and in the second quadrant sine theta is positive. So therefore positive to this one and positive to this one also. So let us see one more example, sine 225. So sine 225 can be written as sine 180 plus 45, or we can write sine 270 minus 45 also. So this is in terms of 180 degrees, so sine remains as sine, so sine 45. So this is in terms of 270 and 90, so this becomes cos 45. Sine 45 is 1 by root 2, cos 45 is also 1 by root 2. Now the question is again whether they are positive or negative. So if you see this 225, so this 225 is present in third quadrant where their sine theta is negative. So this is also negative and this is also negative. So this is how we find out their values. Let us see one more example of this one. For example, the given angle is sine, or let us take a cot now. So cot 750. So this is the given angle. So this cot 750, I can write it as 2 into 360 plus 30 degrees. 2 into 360 is 720, 720 plus 30 is 750. Then 2 into 360 represents that already we have rotated by 2 complete circles, and again we have started the starting point. So that is, this is in terms of 360 degrees itself, so we can remove this value and write it as cot 30. So cot 30, reciprocal of tan 30, tan 30 is 1 by root 3, so cot 30 value is root 3. Now the question is again whether it is positive or negative. So 30 degrees, 750 means it is present in the first quadrant, and in the first quadrant all the values are positive. So we give positive value to this one. So this is our answer. So in this method we can calculate the value of any angle with this simple technique. Okay. So now after this, let us see the most common trigonometric equations which are present, which are very important in solving the problems of physics. So let us see them. So first one, we have sine squared theta plus cos squared theta is equals to 1. So one more thing, I just forgot to explain about the minus theta values. So what about sine minus theta? What about cos minus theta? What about tan minus theta? What about these values? So minus theta represents that this value is present in fourth quadrant, that's all. So in fourth quadrant, this sine value will become negative. So this will become minus sine theta. Similarly, tan theta is also negative in the fourth quadrant. So therefore I can write it as minus tan theta. Similarly, cos theta is positive in the fourth quadrant. So this I can write it as plus cos theta. So here also some of the students may get confused. So you can understand this method. So minus theta just represents that this angle lies in the fourth quadrant. Okay. Now let us see this function. We know this is a very important function. Sine squared theta plus cos squared theta is equals to 1. Now let us see what happens if I divide the right hand side and left hand side by sine squared theta. So sine squared theta divided by sine squared theta plus cos squared theta divided by sine squared theta is equals to 1 by sine squared theta. So sine squared theta plus sine squared divided by sine squared theta value is 1 plus cos by sine value is cot. So cot squared theta. So 1 by sine squared theta can be written as cosecant squared theta. So this is another important relation which we got. Also can be written as cosecant squared theta minus cot squared theta is equals to 1. Now let us see what happens if I can divide the same ratio, same equation now by cos squared theta. So therefore sine squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta is equals to 1 by cos squared theta. So therefore sine squared theta by cos squared theta, we know it is equals to tan squared theta plus 1 is equals to reciprocal of cos squared theta can be written as secant squared theta. So this is another important relation which can also be written as secant squared theta minus tan squared theta is equals to 1. So these are three very important relations which are often used in solving the problems of physics. Okay. So now let us see some more equations. So we have a relation sin A plus B can be written as sin A cos B plus cos A sin B. Sin A minus B can be written as sin A cos B minus cos A sin B. Cos A plus B can be written as cos A cos B minus sin A sin B. So in the terms of cos A plus B, here if I get plus, I will get minus. Here if I get minus, then here I will get plus. So cos A minus B can be written as cos A cos B plus sin A sin B. Similarly, tan A plus B can be written as tan A plus tan B divided by 1 minus tan A tan B. Similarly, tan A minus B can be written as tan A minus tan B divided by 1 plus tan A tan B. So these are some important relations which we have. So in the same relations, let us do some modification. So let us assume A is equals to B. So that is this angle and this angle. If both of them are equal, then let us see what will happen. So let us see the first term changes like this. So instead of b also I will write a itself. So sin 2a can be written as sin a cos a plus cos a sin a. So can be written as 2 sin a cos a. So this is also very important relation which we have already discussed this one in the previous lectures. So sin 2x is equals to 2 sin x cos x. Similarly, let us see this relation. So cos 2a is equals to cos square a minus sin square a. This is also very important relation. Similarly, let us see tan a plus b. So tan 2a can be written as, so 2 tan a divided by 1 minus tan square a. So these are some important relations which we have. So from this relation, which is cos 2a is equals to cos square a minus sin square a, let us see if we can get some more relations. So we have cos 2a is equals to cos square a minus sin square a. Now this cos square a can be written as 1 minus sin square a also, because we know sin square x plus cos square x is equals to 1. So therefore cos 2a can be written as 1 minus sin square a minus sin square a. So cos 2a can be written as 1 minus 2 sin square a. Therefore 2 sin square a is equals to 1 minus cos 2a. Therefore sin square a is equals to 1 minus cos 2a divided by 2. So this relation also we have used in our previous lectures. Sin square x is equals to 1 minus cos 2x divided by 2. So now instead of converting this cos square a, let us try to convert sin square a. So now we can write cos 2a is equals to cos square a minus sin square theta can be written as 1 minus cos square a. So cos square a minus 1 plus cos square a, which is can be written as 2 cos square a minus 1. Therefore 2 cos square a can be written as cos 2a plus 1. So therefore cos square a can be written as 1 plus cos 2a divided by 2. So this is also very important trigonometric ratio relation between cos 2a and cos square a. This also we have used in our previous lectures of integrations and differentiations. Okay. Now let us see one more very important rule in trigonometry, which is called sine rule. So for example, this is a triangle. Let us call this side as length of this side is A, length of this side is B, and length of this side is C. So let us call this angle as alpha, let us call this angle as beta, and we call this angle as gamma. Then how we can write the sine rule is, just we take sine alpha divided by, what is the opposite side of sine alpha is A. This ratio should be equal to the ratio of sine beta divided by the opposite side is B here. So this is equals to sine gamma divided by the opposite side which is present is C. So this is called our sine rule. We have one more rule which is called cosine rule. Cosine rule. So cosine rule can be written as, for example, if you take this angle gamma, I can write it as cos gamma is equals to, then you take the adjacent sides of these two angle gamma. then it can be written as a square plus b square minus the square of third angle divided by 2ab. So this is how we can write for cos gamma. Similarly, if I want to write for cos alpha, then how can I write c square plus b square minus a square divided by 2cb. Similarly, if I want to write about gamma, beta, cos beta can be written as the adjacent sides are c square plus a square minus b square divided by 2ca. So these are very important rules which are called as sine rule and cos rule. From the same sine rule, we can explain Lami's theorem also, which we will study in either vectors or Newton's laws of motion. So this is a brief history of trigonometry. So in the next class, I hope we will start the chapter of vectors, which is also very important mathematical tool. Thank you.